Okay, this is a video about linear number sequences and looking at something called nth term. Now let's remind us what a linear number sequence is. Well, a linear number sequence is just a number pattern following a particular rule. Okay, and if we look at some simple ones here, we could look at 2, 4, 6, 8, 10, and so on. That's a linear number sequence, number pattern. It has a simple term to term rule. Each of these numbers in a number sequence is called a term. Okay, so each of these is called a term, and this happens to be the first term, and this is the second term, third term, fourth term, fifth term, and so on. So every term in a sequence has a position. Obviously the first number in the sequence is the first term, and so on. Okay, and if we look at the difference between each term, of course it is the same all the way along, and that's what makes it linear, and we'll talk about that a bit more later on. Okay, so because the difference between each term is exactly the same in our number pattern straight away, then it's going to be a linear number sequence. So let's look at how we can make sequences. So I was just talking about position there, first, second, third, fourth, fifth. So if we call the position number n and look at the first, second, third, fourth and fifth position and work out the sequence, we'll call it S, for a particular rule. So if I just said let's use this formula to create this sequence, let's say I said it was 3 times the position number n, and that's it. So this sequence is 3 times n, which is the position number. Okay, so we're going to make a note of that. N stands for the position number. Okay, so when n is 1, we're working out the first term in the sequence. When n is 2, we work out the second. So to work out this first term in the sequence S, then we use our little formula here. I'm going to put S equals 3n, so now it looks like a formula. We put the value of n in, so 3 times 1 is 3, 3 times 2 is 6, 3 3s are 9, 3 4s are 12, 3 5s are 15. Okay, that's fairly straightforward, isn't it? Let's have a look at another one. So n, position number, S sequence, position 1, first, second, third, fourth, fifth. This time, let's use the formula S is 3n plus 4. So all I've done is add 4 to my previous formula, and let's see what that does. So we're going to substitute 1 into 3n plus 4 and see what we get. So 3 times 1 is 3 plus 4, 7. 3 times 2 is 6 plus 4 is 10. 3 times 3 is 9 plus 4 is 13. 3 4s are 12 plus 4 is 16, and 3 5s are 15 plus 4 is 19. Okay, that was fairly straightforward as well. Let's look at one more. N is the position number, so we'll work out the first, second, third, fourth and fifth again for the sequence S, but this time the formula we'll use is S equals minus 2n plus 3. So this time we're going to multiply our position number n by minus 2 and then add 3 each time. I'm doing this, out loud and in my head because I know you're capable of doing this. Okay, but if you were unsure, it might be a good idea to write it down on paper. Okay, but with these simple formulae, I know most of you, or for all of you, are capable of doing that in your head. But if you're not sure, always write it down on paper. So for the first one, I'm just going to put n equal to 1 into this, just to show you what I mean. So instead of n, remember we've done substitution. I shouldn't be put minus there. Instead of n, I'm going to put the value 1 because that's what we're substituting in first to represent the first term. And now I'm going to work it out. Minus 2 times 1. Remember, the rules for multiplying with negatives and positives. Minus times a plus is a minus, 2 times 1 is 2, plus 3, and minus 2 plus 3, we're on minus 2 on the number line, okay, there's 0, we're on minus 2, we add 3, and where do we go? Up to 1, so the answer is 1. So that's what you're doing when you're adding and subtracting with positive and negative numbers. You go up and down the number line. Okay, so our first term in our sequence S is 1. Now let's do the others in our head. So put n equal to 2. Minus 2 times 2 is minus 4. Plus 3 is minus 1. Okay, put n equal to 3 in there now. Minus 2 times 3 is minus 6. Plus 3 is minus 3. Now we'll substitute in n equal to 4. Minus 2 times 4, minus 8. Plus 3, minus 5. And then we substitute 5 in and we get minus 2 times 5 is minus 10. Plus 3 is minus 7. Okay, so we've created 3 linear number sequences. Well, how do I know they're linear? Well, I said up here that a sequence is linear if this first difference, that's what we call that, okay, first difference is the same all the way along. And it's also called the term to term rule because we're going from term to term. And it is the same, plus 2 plus 2. So how do I know this is linear? Let's check. What's this going up in? Plus 3, plus 3, plus 3, plus 3. So this is going up in plus 3 all the time. What about this one? From 7 to 10 to 13, that's plus 3 too. Are you noticing something? What's happening with this one? From 1 to minus 1, going from there to there, that's minus 2. Let's just double check. Yeah, that's minus 2 as well. From minus 1 to minus 3, that's minus 2. Minus 2, minus 2, that's going down by minus 2 all the time. So this first difference is the same all the way along here. So it's linear, and that one is, and that one is. But I'm hoping you're spotting that what this sequence is going up in is the same as this number here in front of n. It's going up in 3s, and that's a positive 3 there. This is plus 3 all the way along. What's in front of n? Plus 3. This is going down by 2 all the time, subtracting 2 all the time. What's in front of n? Minus 2. Let's just check that out with another rule then. So if I said, let's test out our theory. So really what this is, the term to term rule is the number in front of n in this formula that I've been giving you to create a sequence. Let's have a look. So if I said create another sequence, let's say just do 5n this time, plus 1. So 5 times the position number, plus 1, and we'll get our sequence, get our first term in our sequence. So 5 times 1 is 5, plus 1 is 6. 5 times 2 is 10, plus 1 is 11. 5 times 3 is 15, plus 1 is 16. 5 times 4 is 20, plus 1 is 21. 5 5s are 25, plus 1 is 26. What's happening? What are we expecting? We're expecting it to go up by plus 5 each time. And lo and behold, it is. Okay, so perhaps what you could do now, if I give you this sequence, you could tell me the first part of the formula. Okay, let's have a look. So let's look at, I'm going to give you the sequence this time for each of the first 5 terms. So we're going to go 4, 7, 10, 13, 16. So the formula to make this sequence using these position numbers, from what we've noticed, let's have a look. What's the term to term rule? Plus 3, double check, always do the first 3 at least. Yeah, plus 3, plus 3, plus 3, and 13 to 16 is plus 3. So it's got to be 3n to start off with, because that's what we noticed up here, that this term to term rule was always the number in front of n, which is our position number. And we use our position number to work out these terms in our sequence. But what's missing? We're missing possibly another part, because let's have a look. Let's write down the sequence for 3n. I'll do it over here. So if I get my pen back up, if I put n again and say first, second, third, fourth, fifth, if we use this formula now that we've got here, 3n, 3 times 1 is 3, 3 2s are 6. Oh, we had this above, didn't we? 3 3s are 9, 3 4s are 12, 3 5s are 15, our 3 times table. Oh, so this, when it's just 3n, it's our 3 times table. But it's not the same as this sequence, is it? Because we're missing, look, well, we must be missing the second part, like this part up here was plus 1. So how can we see what the second part of the formula is to make this sequence here? We know it must be 3n because of this plus 3 all the way for our first difference. But we're doing on the second bit is what we can do is compare the 3n bit that we've got so far with the sequence we want. So if I write underneath 4, 7, 10, 13, 16, now we need to have a look at what do we need to do to our sequence for 3n, 3, 6, 9, 12, 15, to get our sequence. So this is our sequence for 3n. This is our sequence for 3n something. What's the difference from this one to this one? Well, if you look, what could we do to 3 to make it 4? Add 1. Let's check that with the other one. Add 1 to 6, yeah, we get 7. Add 1 to 9, we get 10. Add 1 to 12, we get 13. Add 1 to 15. So this must be the sequence 3n plus 1. So the formula for this one is s equals 3n plus 1. So what we've just done there is I gave you a sequence and said work out the formula that makes this sequence. From what we spotted out above here, that the first difference is always the number in front of our n, our position number, we could write 3n down. And then we wrote down the sequence for 3n and realised it's not quite enough. We had 3, 6, 9, 12, 15, but we wanted 4, 7, 10, 13, 16. So by comparing the sequence for 3n with the sequence we want, we could see that it was just one more we needed to add to get our sequence. So this sequence is this sequence, 3n, plus an extra 1. Does that make sense? Okay, let's have a look at another one. So n, 1, 2, 3, 4, 5. Let's have another sequence. We'll go 2, 4. No, I'm going to change that. Sorry. I'm going to go 3, 5, 7, 9, 11. Okay, what's going on? From term to term, plus 2. Term to term rule, plus 2. First difference, plus 2. So we know that our formula for our sequence must be 2n and maybe plus something. So let's check out what 2n is. So if I write down 1, 2, 3, 4, 5 again and write down the sequence for 2n, 2 times 1, 2. 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10. That's not what we want. We want 3, 5, 7, 9, 11. So we haven't got enough yet. So there must be a little bit that we need to add on the end. So if we write down the sequence we want underneath, 3, 5, 7, 9, 11. What is the difference from our sequence to the one we want? Oh, it's plus 1 again. 2 plus 1 is 3, 4 plus 1 is 5, 6 plus 1 is 7, 8 plus 1 is 9, 10 plus 1 is 11. So if we add 1 to 2n, we get our sequence. So our formula for this sequence is s equals 2n plus 1. So what we've done there now is found the formula that makes a sequence that we've been given, and that is nth term. That is the nth term formula for creating this sequence. And once you have found that formula, you can use that formula to work out any term in any position, because n is the position number. Right, so let's remind ourselves, if you want the first term, you put n equal to 1. Okay, 2 times 1 plus 1 is 3. If you want the second term in the sequence, you put n equal to 2. 2 2s are 4 plus 1 is 5. Third term, 2 3s are 6 plus 1 is 7. Fourth term, 2 4s are 8 plus 1 is 9. Fifth term, 2 5s are 10 plus 1 is 11. So that is what I need you to be able to do. Okay, is find the nth term formula that makes a sequence if I give you the sequence. I'm going to do one more example. Okay, give you a couple of seconds to think about it. So here's a sequence. Find the nth term formula. Right, so s equals 2n plus 1 is the nth term formula for 3, 5, 7, 9, 11. So that's what we found out just now. And earlier on, s equals 3n plus 1 is the nth term formula for 4, 7, 10, 13, 16 and so on. Okay? Let's move this back up and look at one more example and see if you can do it. Okay, so I just give you the sequence. So here's the sequence S. We'll have 5, 9, 13, 17, 21. I'll put little commas in between this time, because you might be given the sequence like that. So if that was a sequence, call it S, 5, 9, 13, 17, 21. What is the nth term formula that makes that sequence? Well, let's do what we've just been doing. Let's put n for our position number and s for our sequence. So we know the first term is 5, we know the second term is 9, we know the third term is 13, we know the fourth term is 17, and we know the fifth term is 21. What's happening between each term? And if we look, it's plus 4 each time. Okay, so we know our sequence, the first part of our formula, must be 4 times our position number, because that's what we discovered in the first part of the video. Is it enough though? So let's write down the sequence for 4n to see if it is enough. Okay, when you get really good at these, you'll be able to check this in your head quickly and realize it's not enough. 4 times 1, 4. 4 2s are 8. 4 times table, isn't it? 4 3s are 12. 4 4s are 16. 4 5s are 20. Okay, we want 5, 9, 13, 17, 21. We've got 4, 8, 12, 16, 20. So we're going to write the sequence underneath. 5, 9, 13, 17, 21. What's the difference? We need to add 1 again, don't we? So this was the sequence for 4n. This is the sequence for 4n plus an extra 1. So the formula that makes our sequence for this question, okay, is s equals 4n plus 1. And that's the nth term formula. Four, 5, 9, 13, 17, 21. Okay, one more. I want you to think of one more. Here we go. Last one. So here's a sequence. Call it S. We'll have 2, 5, 8, 11, 14, dot, dot, dot. What's the nth term formula that makes that sequence? Okay, so we write n, 1, 2, 3, 4, 5, first, second, third, fourth, fifth. What's the first, second, third, fourth, fifth? Here we have it, right? We have 2, 5, 8, 11, 14. What's happening between each term rule? Plus 3. Plus 3, yeah, plus 3. So we know our sequence starts with 3n. Starts with the 3 times table. So if you notice up here, 4m is 4 times table, 3m is a 3 times table, 2m is a 2 times table earlier on. Okay, but is that enough? Well, if you know your 3 times table, you know that's not your 3 times table, 2, 5, 8, 11, 14. So we're going to have to try and work out the extra bit we need. So we'll do it again. So write n, 1, 2, 3, 4, 5, first, second, third, fourth, fifth. The sequence for 3n is 3 times 1 is 3, so 3 times table, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15. What do we want? We want 2, 5, 8, 11, 14. What do we need to do to our 3n sequence to get the sequence we want? And if you look, it's take away 1. Let's check that works for every one. 12 take away 1, 11. 9 take away 1, 8. 6 take away 1, 5. 3 take away 1, 2. So this sequence there is our 3n. And this sequence is 3n take away 1, because it's 1 less than 3n. So our formula is x equals 3n take away 1. And that's the nth term formula. Four, 2, 5, 8, 11, 14. And what I mean by that is this formula makes this sequence. It makes the first, the second, the third, the fourth, the fifth term, like we just did, but you can also use it to make any term in the sequence. So I wanted, you might be asked in a question, what's the 50th term? What is the 50th term? Well, 50th is a position number, so that means, what's our position number? N. So n equals 50. Okay, and so we take our formula, s equals 3n minus 1, and instead of n we put 50 if we want the 50th term. Remember how I taught you how to substitute? Replace the letter with a pair of brackets, pop the value inside the brackets, then bid mass. 3 times 50, 150. Take away 1, 149. Okay, there we have it. So the 50th term in our number sequence, our linear number sequence, would be 149 if we carried on adding 3 to that sequence. But we don't need to, because we have the formula and we can do it in a couple of seconds. And that is the power of algebra and the reason for finding this formula for this number pattern. Because all maths is about patterns at the end of the day, really, and trying to understand those patterns. And we introduce algebra, we look at results, we look at things we spot, and we come up with general rules to understand those mathematical patterns that we've spotted. Okay, and this is a nice example of that. Okay, hope that helps. Thank you very much.